Good morning. Thanks everybody for coming. I'm very pleased to introduce Laura Wingard, the VP of Product Technology at Perforce, and also the author of the O'Reilly book, Practical Perforce. And she's going to give us a talk on branching and merging, and apparently it can be as easy as driving a car. So over to Laura. Thank you.
Thanks very much, Rob. Sound check okay? So
one thing I should mention, this talk will appear on the Google Videos site, so if you have any questions that relate directly to Google technology, if you could keep them until after the talk is finished. Thank you.
This talk's going to go about 45, 50 minutes, then we can have questions. For those of you at home, this is about branching and merging, having to do with software development, large software development projects, and how to manage the huge amount of source code that comes with it. And what we're going to cover here is the difference between the ideal world and the real world. And the reason I bring up the ideal world is because often in the real world we have so many procedures and methodologies that we apply to software development processes that we forget what the original intent was. And the ideal world is an excellent illustration of what we're really trying to do. The scope of our discussion here will be branches of source code. We'll see what those are, and modules within branches. And I'll clarify my terminology as we go along. You'll also learn about the Tofu Scale, the baseline protocol, and the golden rule of collaboration. So little catchwords you can take home with you. We'll discuss the myth of merging, and we'll talk about why we don't drive through hedges. And what I'm hoping is for those of you that are listening and watching this talk is that you'll come out of this with an idea of how to plan for branching and merging in software development projects, and with ideas of how to simplify existing branching and merging processes. So starting with the ideal world. In the ideal world, there are no bugs, everything completes on time, schedules never slip, first release is perfect. Customers always upgrade when you ask them to. If there were an ideal world, we would have a source code repository that we could diagram this way. It would start with nothing, it would end with the perfect release, and in between would be some kind of development. Well, in the ideal world, where we might make one release, and it's the perfect release, and that's all we'd ever have to do, in the real world, the first thing we learn is one release is never enough. Because of the constraints of the real world, for instance, we're not exactly sure what the target requirements are, or the technology changes while we're doing development. What we do to accommodate the real world is we make periodic releases. So now our diagram gets slightly more complicated. That we start with nothing, we develop, we make a release, but then we continue developing and we make another release to get closer and closer to our ideal world goal of coming out with that perfect release. And whereas in the ideal world, there are no bugs, in the real world, of course, there are bugs. So the way we accommodate this real world constraint is we branch the source code we're working on. And in this diagram, we're showing that we develop a little bit, and we have some code that is worthy of release. We branch it so that we can stabilize it, and stabilization is a euphemism for fixing bugs. And now we have, with two branches, we can have two things going on at once. Development can continue in a development mainline, while stabilization can occur in a release branch. This allows us to simulate the ideal world, because for the people working in the release branch, it looks to them like the ideal world of no developers destabilizing code while they're doing the stabilization. While they're doing the last-minute bug fixing, there's nobody putting in brand new untested features. And for those people working in the development branch, it also looks like the ideal world, that nobody is telling them, hey, you can't touch this code because I'm trying to stabilize it for release. So branching is a mechanism whereby we can simulate the ideal world. Now up there in these release branches, this little diagram shows two release branches. In the release branches, we can still make periodic releases, and that too simulates the ideal world of every branch. Every release is perfect. And whereas in the ideal world we have all the time we need, in the real world we have release cycles that have a certain duration, and sometimes they're very, very short. And what we can do about it in the real world to accommodate extremely short release cycles is to have what we call staging branches. These are also known as promotion streams. And that is, you take your development code, develop, 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 you have something worthy of release, you branch it into a first branch here for the first stage of the release cycle. You do something to it. In this example, what's happening is some QA is happening, some testing is happening. When that code has undergone and passed that this series of tests, for example, then you branch it into another branch where a next stage of release happens. In this example, it's the beta release. And then from there, if it passes the beta release, you branch it into a live branch, and that actually mirrors what's available to the customers. And this is a paradigm that's often in use for web content development. Now, what's nice about these staging branches is that they themselves create a situation that looks like only 3 branches. In fact, physically, it's only 3 or 4 branches here. But for each releasable chunk of product, it looks like there's a new release branch being created every week or every day even, depending on the frequency of release. So what I'm showing here is, here's some work worthy of release, and it goes through 3 branches, but if you squint your eyes, this is actually just like the release branch we saw in the previous slides. So we can have a huge number of these, and with only 1 development branch and 3 additional staging branches, it can look like we're having a branch every week or a branch every day. And the end result of that is you still have your frequent releases here. These can be coming out every day, and you're doing this with just 3 branches and a main branch, a main development branch. So again, this creates the illusion of the ideal world for the people having to do this work. And whereas in the ideal world, all development finishes on time, as we know, development is subject to the vagaries of the real world, where schedules can slip, resources can disappear or be constrained. So what we do about it in the real world, again, we branch our code so that we can decouple the development projects that have certain dependencies on each other. If we did all our development in 1 branch, a development mainline, any one project that got held up could hold up the release of all the other projects, because all our code is in the same repository or in the same branch. So to get around that, we branch into different development branches, 1 for each development project. So if 1 development project, for example, we branched here to do the Project X development, that was a very short amount of development. We got finished with it quickly. We delivered the completed result back into the development mainline. Project Y took a little longer. We didn't complete it until this point, but at which point we delivered it back into the mainline. Project Z, still ongoing. We don't even know when that's going to finish. But it allows us in the development mainline to still do periodic releases. We're not waiting for the slowest of the projects to get done in order to do a release. We can do a release as frequently as anything is done. And again, this creates the illusion of the ideal world. For the point of view for anybody working in any of these branches, if you're working in the Project X development branch, it looks to you like the ideal world, where you're not being held up by the slow work in Project Z or in Project Y, because as soon as you're done, your stuff is ready to release. It goes into this development mainline. From the mainline, the illusion is that everything that's checked in is right the first time. That in the mainline, what happens is code gets promoted or delivered from these development projects into the mainline when they're complete. So you don't see points of instability in the mainline. So there is another simulating the ideal world where there's no instability. And then for the Project Z development branch, the illusion there for the Project Z developers is they have all the time in the world. That all the other projects are not held up by them and are not emailing them and not having panicky status meetings saying, when are you guys going to be done? And to them, they have this nice illusion of, their world has a long release date. So when we put all these together, you get that picture of what we call the mainline model, where we have a development mainline that creates the illusion of the ideal world, where we would all develop in the same repository using the same files. The files are only updated when we have completed work, and once we come up with releasable code, that's all we need to do with it. Because from the perspective of the mainline, we don't see what's going on in the release lines. That stuff is removed from the mainline, and we don't see what's going on in the project lines. We only see completed development as it comes into the mainline. Now, changes do happen in all these branches. In the project branches, of course, major churning development changes happen. In the release branches, bug fixing happens. And somehow, all those bug fixes and all that development has to get into the mainline. Certainly the project work has to get in the mainline, because we're making our releases from the mainline, or we're branching release branches from the mainline. And we would like all the bug fixes to get from the release branches into the mainline, so we don't have to fix the same bugs in many different places, or that is, so we don't have to duplicate bug fixing efforts. So this is an extremely simple, little simplified diagram of the mainline model. In the real world, it doesn't usually look like this. It's usually much more complex. Here's the same diagram showing these promotion streams. Still, changes are flowing throughout the system. And this leads to the question in the real world, is this anything but chaos? And if changes are flowing from branch to branch, and you have hundreds of developers working in each branch, releases scheduled at varying frequencies, and projects galore and deadlines galore, how can this be anything but chaos? And as an example, this is a revision diagram of a single file in a fairly small system with about 20 branches and 30 revisions. So this is just one file in a system of, say, 10,000 files. So imagine if you had a system of 100,000 files and 300 branches. How can this be anything other than chaos? Well, it's not necessarily chaos, in the same way that driving is not necessarily chaos. And what we often don't realize is that driving is an extremely complicated thing. And I like to point out that if any one of you was called upon to rush to a customer site or a development site in another city, you could get on a plane, get off the plane, rent a car you've never driven before, in a city you've never been before, get in the car, get on the freeway, drive at 70 miles an hour, get to a customer site, make a bug fix, and you will not have gotten into an accident. You haven't really even put yourself in danger doing that. But you make the bug fix, and then you're at a loss to how to merge it into the main line. You have to start looking up in procedure manuals, what is our procedure here, get authorizations. So there's this perception that merging and everything having to do with branching and merging is extremely complicated. But it's not really complicated. What's complicated is that we have to make those decisions anew because we don't really make use of protocols and maps and etiquette as we do with driving. So what I'm going to do in these slides is show some of the protocols and maps and etiquette that I've learned from customers I've worked with. And I'm going to continue to harp on the driving analogy to show that what looks like a very complicated thing is actually a simple matter of just following the protocol at each decision point, and it can be as easy as driving. So the first thing that helps is the same way you orient yourself with a map of roads, and you know that north is on top and south is on the bottom. In managing branches, it's good to think of the Tofu scale. Firm is on top, soft is on the bottom. And so what is this Tofu scale? It's a way of assessing the relative firmness of every branch relative to the other branches. And firmness is a matter of how much the code has been tested, how big the changes are that are occurring in it, how close it is to release, and ultimately the risk of making a change. So each of these branches has a relative rank on the Tofu scale. At the very firmest end, we see these release branches, and then there's a little patch branch off of the release branch. In the release branches, code is very much already tested. For the most part, this is code that's, it's either about to be heavily tested or it has been heavily tested. It's also either about to be released or it just has been. It has already been released. At the opposite end, as you go down the Tofu scale, at the opposite end, you get development projects where code is just the opposite. Much of what gets checked into development branches hasn't been tested. It's not even known to work, might not even build. It'll be months, maybe even years before customers see the results of this code. And somewhere in the middle is your development mainline. It's neither too soft nor too firm. Now, one thing you can get from this is you can see at a glance the risk of making a change. So just as you can look at a map of roads and find out, you can tell by looking at the map where you can drive the fastest, because you can see the freeways and you can see the surface roads, and you make a mental assumption that this is the difference. The same way you can look here and you can say, whoa, if I change something high on the scale, high on this diagram, it's going to hit customers soonest. And if I change it low, if I check a change into a branch that's low on the scale, it'll be a long time before customers see it. But the inverse of that is, if I make a change to a branch that is high on this diagram, the risk of making that change is extremely high as well. And the inverse is also true. If I make a change to any of the branches at the bottom of the diagram, the risk of making a change there is not as high. And that's because for these branches on the bottom of the diagram, all of their testing is pretty much ahead of them. Whereas for the code and the software that's in the firmest branches, they've already been tested. And if you make a change, you have to make a choice between two things: starting the test clock all over again or going out without adequate testing. So that's the Tofu scale, and that's one way we orient ourselves to how branches relate to each other in a system. This, you can use the Tofu scale also to look at these staging branches. You notice that each branch through the development cycle is firmer and firmer and firmer, and then you have your live branch from which perhaps maybe your website is mirrored, and that's the firmest of all. If you make a change in the live branch, that's where your greatest risk is. Now, another thing we can use, I have to shift around on these slides if I get this right. Is this what I want? Oh, go back here. Now, a protocol that helps us simplify the whole process of branching and merging is what we call the baseline protocol. And actually, let me go back to this slide for a moment. What you see here is basically a timeline. Each of these branches, like the Project Z1 branch, has a parent, which is the Project Z branch. But from now on, I'm going to refer to a parent as a baseline, because parentage implies some sort of superiority, and you tend to picture the parent above and the child below. But as you see, once you apply the Tofu scale, some parents are below and some children are above. So what we say is, release 2x was branched from the main line. Its baseline is the main line, so its baseline is below it. The project branches, their baselines are above them. And the reason I want to use the word baseline is because I want to talk about the baseline protocol, which is analogous to driving. When you drive up to an intersection and there's a stop sign, all there is one little sign, and it says stop. But that expresses this huge protocol, depending on, you look around, you see how many other stop signs there are, you see how many lanes you are, you see whether or not you're in a one-way or a two-way street, you see whether or not there are other cars. And the protocol for stop also includes, you put your pedal on the brake, you watch your speedometer needle go down to 0. One little sign that says stop tells you all this. And it would be nice if there were something in branching and merging, that we could just see one little thing and we would know what, what we need to do when it comes to merging a change. Well, there is a protocol that we can follow that can simplify things to that level, and that's the baseline protocol. And here's how it plays out. So when a branch is firmer than its baseline, if you make a change to that branch, oh, actually, let me back up. The baseline protocol, first of all, change flows between a branch and its baseline. Change never flows between two branches not connected by the baseline branch relationship. So how and when change flows is this little table here. So if a branch is firmer than its baseline, for instance, a release branch we saw in the previous slide, tends to be firmer than its baseline. Change flows from a branch to its softer baseline continually. When a branch is softer than its baseline, as in a project branch, a project development branch, when does change flow up to its baseline? At points of completion. Change flows from the baseline to the branch, that is in the other direction, if the branch is firmer than its baseline. Release branches are firmer than their baselines. They're on top on the Tofu scale. When does change flow from the baseline up to the release branch? Well, we say never, because the whole point of making a release branch was to create this illusion that your coding is done and now it's time to stabilize this release. So if you're pulling stuff in from a baseline, for instance, the main line, you're pulling in new development and you're defying your goal of having a release so you can stabilize. We say never in quotes because this is a part of the protocol that's most often violated. And if a branch is softer than the baseline, for instance, a project branch is softer than their baselines, which are either other project branches or the main line, when does change flow from the baseline to the project branch? Continually. And I will show a diagram. And that brings me to the baseline map, which is a different way of looking at the diagram. Now, whereas this is a timeline, you see all the branches and their relationship to their baselines. This is a timeline that shows you pretty much when the branch happened. It doesn't show you what's going to happen in the future. This is the same branches shown in a different type of diagram, which I'm calling the baseline map. This is a schematic showing which branches relate to which baselines. So project Z1 is a branch whose baseline is project Z. Project Z's baseline is the main line. Release 1X's baseline is the main line. You can use the baseline map, still plotted on the Tofu scale. And again, remember, change flows only between a branch and its baseline. So these orange lines here are where change can flow. Now what you can see is when you apply the baseline protocol, change flows down continually. So for every release branch here, if you make a change in release 1X, that change gets merged into the main line pretty much as soon as possible. If you make a change in project Y, that change goes into the main line when project Y is at a point of completion. That is when the code in that branch can be built and tested and pass all of the tests that the main line requires it to pass. Then change can flow from project Y into the main line. Project Z1, that branch, when does that code flow into the main line? Never, because you can't jump over that intervening branch. You have to follow the branch to baseline routes. But Project Z is a little offshoot of Project Z1 is a little offshoot of Project Z. Its changes get merged into delivered to Project Z when the work in the offshoot is completed, and so on and so forth. An advantage of using a baseline map over a timeline is that you can actually change the relationships of branches. And I mentioned that the direction of the flow of change flowing from a main line up to a release never happens. Well, sometimes it does happen. And you should actually, we consider that's the case where, you're on the road, you need an ambulance. It's not a normal thing. Oh, here's an example of when that's most likely to occur. At one point, the main line was ready to release some code. We branched off release 1x. Then the main line continued to evolve because a lot more development was occurring there. Then we branched off release 2x, and then the main line continued to evolve. Now, what's the relationship now between the code in release 1x and the main line? The code is very different. A lot has happened in between there. So what happens when you have a bug that was found in release 1x and you fix it there? Which is closer to the 1x code, the main line or the release 2x code? It's the release 2x code because this was branched some time ago before the main line had evolved even further. But the problem is, if we have to follow these routes to get bug fixes, to get changes propagated from one branch to another, that's going to be very difficult trying to merge a change from release 1x into the main line and then up to 2x because the main line is so much more evolved. But with a baseline map, you can look at it as a guide to the future. So once all this evolution has happened, you simply rearrange your baseline and say, okay, from now on, all our changes in 1x, we're going to rebase 1x on the 2x code line. So that as bug fixes come into 1x, its baseline is release 2x, so all bug fixes flow from release 1 to release 2. Those two branches are much closer to each other in content, and then they flow from there into the main line. So this is actually, for development, this is great because you've likely had to make a slight modification to bring a 1x bug fix up to the 2x code level, and then the amount of work you have to do to get it from 2x in the main line is even less because you've already done that work. Okay, so one thing about this baseline protocol is that if you are in charge of branches and you have developers working in branches, developers will come to you and say, that's not fair because there's a bug fix in a development branch that I need, and I need to get it in that release right now. And why do we have to follow the baseline protocol? And so I say the answer is, for the same reason, that you have to drive between the lanes and not drive through the hedges. So the driving through the hedges analogy is you're driving along the freeway. It's, there's a beautiful hedge on each side, and just on the other side of the hedge is your destination, maybe a Target store or something. It's just 100 yards away. The freeway exit is, 3/4 of a mile down the road. In order to get to the Target store, you have to drive 3/4 of a mile to the exit, drive back on the frontage road to get into your destination. Nevertheless, you don't see a lot of people standing at the side of the road arguing with highway patrol saying, I don't see why I can't just drive the hedges to get to the Target store. So we remind developers that your repository works the same way. Your source code repository works the same way. You can branch and merge changes. You can merge changes between arbitrary branches. But in so doing, you create a dangerous situation in your repository. So now I want to look at how the flow of change relates between release branches and their baselines, and compare that to how it relates to development branches and their baselines. So here's an example. We saw this before, a branch we're calling release 1x. Change flows, as we know, continually from release 1x to its baseline, which happens to be the main line in this example. This helps with our goal of creating an ideal world, because every change we make to release 1x, which is a bug fix, of course, trickles into the main line, so it has an improving effect on the main line. So we are achieving our ideal world goal of having a product with no bugs. So every bit of progress we make in the release branch has an effect on its baseline, in this case, the main line. And as I said, what we would like is to have a well-ordered enough system so that change does not flow from a baseline into a release branch. That's because the whole reason we made the release branch was to take a snapshot in time and say, this is our release, this is what we're going to perfect. If we were letting changes come up from a baseline into a release branch, we would be defying our ideal world goal. But in some cases, it's unavoidable. We discussed one example of where a change might have to hop over branches. Another is we may have branched too early, that we have a body of code, we think it's ready for release, we branch it into a release branch so we can stabilize it, and then we realize we have actually more significant development to do, and we might have to pull code from the main line. But again, that should be an ambulance situation. So when you find you've made a release and you're still pulling code from the development mainline into a release branch, it's like a stretch of freeway where there are always ambulances. So you have to wonder what's wrong with that stretch of freeway. That maybe a little redesign would be useful. Now the relationship of a development branch to its baseline, shown here, is that, as we saw, change flows continually to a development branch from its baseline. And so any changes in the baseline, which are stabilizing changes, will tend to have an effect on the development line. Because remember, changes are coming into a baseline from their firmer branches. So you've got changes that are creating even more firmness coming into firmer branches, and those changes are trickling down to softer branches. So this has a stabilizing effect on the whole code line. So all the stabilization you do in release branches actually eventually has a stabilizing effect on the lowest of the branches, the project branches, because of this protocol that change continually flows in the downward direction. In the opposite direction, when you're going from a development branch to its baseline, as we said, change only flows when the development branch is at a point of completion. So it's a gated flow. And it's open only when the code in the development branch can pass the test, basically, that can be applied to its baseline. And here in our small system, we see the project. Sorry about that. The Project X branch was, whose baseline is the main line. This is a very small system, and there could be more layers in there. So, and that brings us to the golden rule of collaboration. If you are a branch, the golden rule of collaboration is that you always accept stabilizing changes, and you never impose destabilizing changes. Now, when I say change flows from branch to branch, actually change flows between files in branches. As we know in software development, the tools we use operate on files. This is fairly the smallest unit of granularity for compilers and debuggers and so on and so forth. We can't put all our attention on individual files, so we organize them into directory trees, and we put those directory trees into what I'm calling modules here. Sometimes they're called components, sometimes they're called subsystems. But basically what it is a tree of files that any tool you use has enough of a scope to be useful. So if you're, if you're using a compiler, the module that you're compiling is the module that contains all of the files that the compiler needs to reference to put together a fully linked executable or whatever it is you're building. And modules, what we like to do is when we take all of the files in our software system is divide it up into modules that are small enough to be as small as possible, that a developer can work on it without needing any external files, and yet still have all the dependencies to use all of the tools on that tree. Sometimes modules can be nested, by the way. I mean, you might have some tools if you're just doing, if you're working on documentation, you might just have the actual text of the document module on disk while you work on that. But then whoever builds the product has that and combines it with the binary images and whatever go into the product. But the point is that when you branch a branch, you're actually branching a collection of modules. And when you branch a branch, not all modules are needed in every branch. So here's a main line that might have the large collection of, the sum total of modules that comprise our software system. When we branch a project, a development branch to work on a project, we might only need a subset of that. So what we branch is the bare minimum of modules needed to get the development work done. Same goes to for sub-branches of that. We may or may not need, the entire subset, or we might even need fewer modules. When we branch from our main line into a release, we pick the modules that are going to be the target of the release. I mean, the software that we're releasing. So every branch has some number of modules that live in it. Yes, sir?
What if you go from X to X1, but you need more modules from the main line?
So the question is, what if you go from X to X1 and you need more modules than are in this project? So this would be the case where you're creating modules. Is that correct?
No, you need them from the main line.
Okay, you're mixing and matching. Can we talk about this in the question and answer? And we'll go through a couple other things first. So I love your question, but it'll take a sidetrack. And the reason I bring up modules is because when you look at how change flows between branches, you can actually narrow it down to how change flows between individual modules. And then you realize there's actually some simplifying rules you can apply. So change flows between any two corresponding modules. A module in one branch, change will flow to the corresponding module in the baseline, back and forth. We can think of a few kinds of modules. One kind is private modules. And change never flows between private modules, although the same modules can exist in a branch and its baseline. And a perfect example of a private module is a module or a directory of files that is created by nightly builds or created by builds. Those files are used in the context of working on the files in that branch. If you're working in the Project X development branch, there may be nightly or periodic builds that create some tree of binaries. All your tools reference that. You pull those onto disk. But we never merge changes back and forth between the binaries in the module, in the bin directory in Project X with the bin directory in the mainline. What we do is we rebuild them in the mainline. These source files may be merged into the mainline. At the mainline, we build our own bin directories. So here's a class of modules that we don't have to worry about for merging. They exist in all our branches, but they are never the subject of merging. There are also modules that we consider virtual. And these are modules that you bring along into a branch so that anybody doing development in that branch can pull the entire set of modules from the branch onto disk and have everything they need to use certain tools, like compilers and et cetera. Not all of those modules will be subject to development in that branch. So in the Project X branch, for example, we may have branched several modules from the main line just so we have a complete reference set of the modules we need. But we're really only working on the X module, for example. So here's where our development occurs. But we have this complete set of modules so that our tools will work and so that we can compile and link product. These modules that we're not working on, I'm calling the virtual modules. We could also call them inactive modules. These virtual modules are essentially mirrors. So what we would like is, as we work on these modules, that these modules are constantly mirroring what's in the baseline branch. And then the modules we're working on are the active modules. These are the modules that we're also we're submitting changes to. Oh, actually, the point I wanted to make on the previous slide is these virtual modules, they are mirroring changes in the baseline, but we're never merging changes back and forth. Because they're virtual, we're not making changes here. Their changes may be made there that are just appearing here by one way or another. But we're never having to merge because we're not doing any changes here as well. But then when you get to active modules, changes are occurring in both places. So a release branch is typically a situation where you take a bunch of modules from the main line, you put them in a release branch, and then wherever bugs hit, you fix that bug in the release branch. And also in the main line, since that's constantly being updated with new development, you have a situation where you will need merges. So remember that in the release branch, change is always flowing down continually. But no change actually flows up from the main line because that's part of our protocol. No change flows from the main line to the release line. So merging only happens in the main line. Things come down from the release branch to the main line. Things are changing in the main line because they're also coming from development branches. So that's where merging happens. Now, where project branches are involved, we have two-way change flows in two directions in the active module. So now we're getting to the crux of the situation here. These are the things that we're going to have to put all our work into when it comes to branching and merging. So active modules in project branches, because change is flowing in both ways in those modules, and they eventually will need merging. So there's a fear of merging, or there's a myth that merging is dangerous, and a lot of times software projects try to avoid any kind of merging. But the truth is that merging isn't really any more dangerous than coding. It has the same risk as coding. You still need, merging can result in incorrect code. You still have to test it. You still have to have a way to assess whether or not it's correct. So merging itself isn't any more dangerous than coding. But one of the things we can say about it, in as much as it is probably at least as dangerous as coding, is that it should occur in the softer code lines, just as coding should. You wouldn't do any feature development up in a release code line. For the same reason, you probably shouldn't do any merging up in the release code line. And so in the next few slides, we'll see how the flow of change keeps us from having to do any of that risky merging up in the release code lines. So the protocol that keeps all this safe is the merge down, copy up protocol. And that is that as long as change is flowing down, it's okay to merge. So if change is coming from a firmer branch into a softer branch, having to do the merge in the softer branch is okay, because the softer branch, being the softer of the two, is more commodious of the change, and there's less risk involved with doing the merge there. When change needs to go in the opposite direction, for example, when you're delivering completed development from a project development branch to its baseline, we copy the files. So we never have a situation where we have to merge in the firmer branch. But of course, the only way we can do that is to make sure that the project branch is completely up to date with the baseline. So all the changes have been merged down from its baseline first. Then we've done whatever testing or validation we need. Then we simply copy the files back. And here is where an etiquette of branching and merging comes into play. And that is that during that time, between the time that we've merged down and we're doing the testing, before we prepare to copy back, the people who are doing their work in the baseline, which in this example is the main line, have to stop so that we have time to deliver our completed code, that is, copy our code up into the baseline. And how much time is that? It's not very much, because remember, changes are trickling continually from the baseline. So any development project is fairly close. It's never far from being completely up to date with its baseline, because the protocol is that changes get merged down continually from a firmer baseline into a softer branch. So the amount of time that we need to basically freeze the baseline in order to copy these up is very small, basically just enough to do the final testing for the last increment that we've merged down. So when you apply those protocols and the maps, the orientation of the maps, and a little bit of etiquette, you see that, in fact, it's not chaos. It's no more chaos than driving on a road, because every time you come to an intersection, you know exactly what to do. So that every change you make, you know exactly where to make it when you apply these rules, and you know exactly how the change has to flow from one branch to another. And you can also, one of the things about this is you realize that you can look at a diagram, either this baseline map diagram, or you can look at the timeline diagram, and you realize that any branch you look at, you can tell what its situation is relative to the other branches. For instance, what's the state of Project Z? Well, I know Project Z has every change that's been in the main line is in Project Z, at least for the scope of the modules that are in Project Z. That there's no bug fix in the Release 1 branch or the Patch 202 branch that are not also in Project Z, if they are relevant, of course, because as you know, sometimes you merge and there's no target file to receive the merge because so much change has happened. Another thing about this system is this is a diagram of a whole system, of a very, very tiny system. But even in the largest system, it's a very regular relationship between any two objects here. That you have a branch and its baseline. Its baseline is either softer or firmer than it. The relationship of a branch to its baseline is exactly the same as the relationship of its baseline to its baseline. So that the relationship is very regular and is uniform throughout the system. And enough said, and I will just summarize here that to follow on, that uniform system, one of the things that we do is we think in our minds that we have roughly 3 kinds of branches. We have the main line, we have release branches, and we have development branches. Now, of course, there are a lot of variations of those, but it's like looking at a map. We understand, basically 2 kinds of roads, I would say. We understand freeways and we understand, surface roads, and we know that there are different rules that apply to them. So when you look at branches, I mean, every branch has a rough category. Is it a release branch? That is it firmer than its baseline? Or is it a development branch? That is, it's softer than its baseline. We do our diagrams. We use the Tofu Scale for diagramming, which gives us an instant recognition of where the risk is. We know that change flows between a branch and its baseline. We know that when change flows, we merge down and copy up. And we know that only the active modules need merging, so that the amount of merging we're doing is not as much as it looks like when you look at the number of branches that we're working with. We know that from the perspective of any branch, we always accept stabilizing change, and we never impose destabilizing change. We know a bit of etiquette, and that is that if we're working in a branch, that we must yield to delivery of completed development. That if any branches have our branch as the baseline and they are going to deliver some completed development, we give them a moment to get their tests in order and do their copy. And we also know that we don't drive through hedges. It's what we've learned here. And so there you have it, the flow of change. And I will take questions now, and I want to start with your question. Remind me again what your question was.
Mainline, Project X, Project X1.
Okay, we have mainline, Project X, and Project X1. Let's see if we can. Oops. Okay.
Okay, so
We have Z and Z1.
And when you make a branch, you took a subset of modules.
That's right. So when we branched Project Z from the mainline, we took a subset of the mainline as modules, and then we branched Z1. Maybe we even just took one module. This was for one little sidetrack project here. Okay.
Well, what if you need an additional module that's in mainline?
One moment, please. Technical adjustment here. So in order to assess the correctness of the work we're doing in Z1, you say there's a module in the mainline we actually need. But that's not an active module, correct? We're not changing that module?
Make it hard. See, it is active.
Say it is an active module. Well, in that case, what you probably need to do is branch that from the mainline into Project Z, or rebase Project Z1 to the mainline so that you can branch that module into Z1. Because if it's an active module, it's an active module. Now, there are the cases where you have shared modules. And these are active modules that are mirrored in each of your development branches, but they are the same module and they're active. So I didn't discuss those on the previous slides, but those are the same kind of situation. Now, the advantage of those modules are you never need to merge them because it's the same module. So this would be a module that exists in the main line. When you're working in Project Z, you might have, maybe the way your directories are laid out, you might have the illusion that that module is in the Project Z1 branch, but when you make changes to it, you're actually directly changing the main line. That is one way to implement a shared module. But the nice thing about shared modules is they don't require merging. Does that answer your question? Okay. Anything else? Yes, in the blue T-shirt in the back.
Hi. I would like to ask about major changes from baseline to software projects.
From the base
Software projects.
to softer projects. Okay, for merging changes from the baseline to softer projects.
Well, I think the first, it's not necessary. Well, the second is usually not possible. Well, suppose we have some project, well, let's say compiler, and we do all the development in the baseline. Then, well, suppose we have an release and we have stable branch, and well, our project manager says, well, your front end is sucks, and we decide to rewrite completely our front end. So we make a development branch.
So are you making okay, so the scenario is you have a release.
Yeah.
It's turned out it's not such a good release, thumbs down, and now you need to do development in it? Is that your question?
No,
or is that?
we have a baseline. At the same time, we are releasing our product. And a group of our engineers, at the same time, is developing a new generation of our product.
Yes, so new development is occurring, yes.
So we put all our bug fixes from our release branch to our baseline.
Yes,
It's okay.
yes.
But the problem is when then we put these bug fixes from the baseline to our development.
Yeah,
Our software engineers say, right, well, we are developing our front end, and we do not need all the bug fixes. And all these bug fixes will interfere with our own changes. And, well, our front end is actually not working now, and a lot of changes we simply can't manage.
okay, I think I get your question. And it has to do with, say the team working on this project, the impact of changes trickling down from the firmer branches can be annoying. And there's two factors there. One is, while you're working in your project development branch, you can have such destabilization that you can't really merge anything in. It's just extra overhead. You can't compile it anyway. Why should you merge in other changes? It's only going to break it even worse. I mean, it's already broken. It's going to be worse. The other is, if the merging is difficult, that is, you're tearing your hair out saying, please, we're trying to develop, and now you're asking us to merge these changes, that's too much work. The second thing, if merging is difficult, that's a symptom of change is not flowing continually enough. Because ideally, two kinds of change flow down here. Bug fixes that are stabilizing and can only be to your advantage to absorb into here. And new development that comes up here, it's complete, it's tested, and now it comes down to here. But it's not in the modules, it's not in your active modules. These were hopefully on separate modules. So these should coexist with yours. Now, sometimes the actual act of doing the merges is difficult, but that's usually a symptom of changes getting backed up. Analogous to a traffic jam. Sometimes driving on the bridge, trying to get across the bridge, you sit in a huge amount of traffic. That's not a symptom of the fact that the bridge shouldn't be there. It's a symptom of the fact that the flow of traffic isn't as regular and the load is not distributed as much as you'd like. So, does that answer your question?
Well, I would like to say if our changes are small, if our development changes are small, we usually don't bother to make another branch. We can just do
Yes.
them in baseline. But well, if our changes is very big, if we want to rewrite a part of the system completely, then well,
Yeah.
actually then this is the case where we need a branch, and then we simply cannot.
Okay, so the case where the reason you're branching to begin with is because the changes are going to be so significant here that you can't possibly do them in a branch where you're sharing with other developers. So once these changes are so significant, why merge other changes to it to code that no longer is relevant? And that's a decision that you have to make at merge time. So all of your changes, this is actually one thing I didn't talk about in this talk, but merging changes from one branch to another basically can have three dispositions. One is you can actually do a merge. The corresponding files can be merged. Another is it might end up being a copy because the target files didn't change. A third is you might want to ignore those changes because they're no longer relevant. You're never going to want to merge them. Is that correct? Is that what you're getting at? Yeah, so that's a case you have to take into account, and which is one of the, it's one of the advantages of using a system like Perforce, which can actually keep track of the changes that you evaluated and said, we don't want these, that these are the ignore integrations that you see in Perforce. I hope I've answered your question. I'm going to get on it. Dan, you had your hand up.
Yeah, just to put this in perspective for people in the audience trying to how to manage Google's infrastructure, or you're wondering, we don't follow your guidelines in a number of ways.
use.
I don't mean to see that many people in the audience who have been here longer than I have, but for you or for people asking questions, don't assume where this matches our development.
Right. Now, so what Dan has just said is that sometimes implementation doesn't necessarily match what you've seen here. But if your implementation has a regular flow, it may be that what you're doing is you're doing development in release branches, or you're releasing from development branches, or you're somehow slightly misusing the protocol that if you reevaluated it, you could normalize what you use your branches for, achieve this same result, which is, you know, a constant flow of small amounts of changes, high quality, without actually making a lot of changes to your system itself. You just need to change the way you approach merging the changes. Anyway, according to my clock, our time is pretty much up. I'm real happy to take your questions afterwards and talk about specifics. And thank you very much for being here, and we'll talk afterwards.